So the problem that we will be looking at is called sort colors. It's problem number 75 on Leetcode, wherein you're given an array nums with n objects that are colored and we have to sort them in place. So this is an important thing, that we have to sort them in place so that objects of the same colors or the same numbers are sorted in the adjacent order. Okay, and we have also been given that that the array will only contain three numbers, that is 0, 1 and 2. Okay, and we have to solve this without using the library sort function. That makes sense. Okay, so if we have to then array this, after sorting it will become 0, 0, 1, 1, 2, that is sorting in ascending order. Okay, so we can use any of the sorting techniques, that is merge sort, bubble sort, quick sort. Like merge sort will use O of n log n time, but this problem is a little bit simpler than that. By simpler I mean less complex than that, because you can see that we only have three numbers, that is 0, 1 and 2, right? We don't have an n number of integers, we just have three integers and we just have to sort them. That is, let's say you can sort them like this. If this is the array of 0, 1, 1, 1, 2, 1, 0, 2, all we have to do is do something like this. That is, all the zeros will be on the left hand side, all the ones will be in the middle, and all the twos will be at the end. That's a sorted array, right? So this is the answer that we have been looking for. So what you can see is that the zeros are coming on this side, that is on the left hand side, ones in the middles and twos at the end. It's almost as sort of a bucket. We have the 0 bucket on the left, the 1 bucket in the middle, and the 2 bucket on the right. So the popular approach to solve this problem was proposed by Dijkstra. It's called the Dutch national flag algorithm. It's called that because it consists of red, white, and blue respectively. Since 0 is red, or 1 is white and 2 is blue, so it forms the color as in this is red, this is white, and this is blue. So it forms the national flag of Dutch. Okay, so how can we solve this? So let's see. Let's say we have this array given. Okay, right. So to solve this problem was proposed by Dijkstra. It's called the Dutch national flag algorithm. It's called that because it consists of red, white, and blue respectively. Since 0 is red, or 1 is white, and 2, we can have three pointers. The first pointer will be pointing here, the second pointer will be pointing here, and the last pointer here. Now why did we take three pointers? We can have three pointers. The first pointer will be pointing here, the second pointer will be pointing here. Three pointers because, as I said, or that we have three buckets, so, and three numbers, so we have one pointer for each of them. So we can call them anything, but I'll be calling the ones that are in the middle, so I'll be calling them, we have one pointer called M, we have one pointer, let's say it's calling start or S, and we have one pointer E. Okay, so initially E is initialized at the ending position, or the ending index, that is length of the array -1, and both mid and start are at the 0th index. Okay, right. So the first thing that we will be, so what will be comparing, or which pointer will we be checking? We will be checking this mid pointer, M. Okay, so there can be three cases, like there are three numbers, so either mid will be 2, either mid is 2, or mid is 0, or mid is 1. Right, we can only have these three cases, and for each mid will be 2 of these cases we will be performing some actions, and that is the entire algorithm. Alright, so let's first check for mid is equals to 2. When mid is 2, we know that 2 will be present at the end of the array, right? So we have to move this 2 at this position. So remember, we are comparing mid, so the thing that we will be doing is that we will be swapping mid with the end position, right? So what will that become? This 2 will be gone, over here it will be 0, and this will be gone, and over here it will be 2. And what we will be doing is that we will be decrementing the end pointer by 1. We will not do anything to the mid and the start pointer. Why will we not do anything? Is because that here we got 0 at the end, but we also could have gotten 1, right? The 0 after swapping, 0 is coming at the starting index. That is what we want. But let's say what if there was an array when the ending index was 1? Then after swapping, the array would have looked something like this, right? It would have looked, after swapping, here would have been 1, 0, 1, 0, 2, 1, 1, or whatever the values, and here ending would have been 2. If you might have been thinking, why did we not increment the start or the mid pointer? If we would have incremented the start or the mid pointer, they would have been pointing here, and the end pointer would have been pointing somewhere before here, right? Somewhere before end. So then this position would have been lost. There was no way we could have reached this position. This should have been a 0, but here it is 1. So that is why, since we don't know since we know the number at the starting index and we don't know the number at the ending index, we are just swapping these two and decrementing the ending index and not incrementing anything with the starting indexes. Okay, right. Okay, so now the middle index is at 0, it's pointing at 0. When the middle index is pointing at 0, we'll swap, we'll do nothing, we'll increment these. So we'll swap start and middle. I'll tell you why we are swapping start and middle, but we'll just increment both of these to here. 1 second, if I can do this correctly. Okay, right. Again they're pointing to 0, we'll do nothing, we'll just keep on advancing this after swapping. Okay, we'll swap start and middle, and then we'll keep on advancing this. So now again the middle is pointing at 2, and now again we'll do the same thing. We'll swap the middle with the ending index, that is, we'll cut this out. Here it will be 1, and here it will be 2, and we'll decrement this. Okay, now the middle index is pointing at 1. When the middle index is pointing at 1, we'll just increment the middle index. Why we are doing this is, see, because we will again have to swap. We can see that there is one more 0 over here and one more 0 over here, right? So we have to swap. So we need something to keep a track of what to swap. So we know that 1 will not be here, this 0 or this 0 will be coming here, and this has to be swapped. So we are keeping a pointer here, and we will only increment the middle pointer when we encounter 1. So this gets incremented here. Again we encountered 1, this gets incremented here. Again we encountered now 1, so this gets incremented here. Now the middle is pointing here. Now the middle is 0. When the middle is 0, we will be swapping this middle index with the starting index. See, this is why we kept the starting pointer here, because we know that this 0 would be going here, right? So what we will do, we will be swapping starting in the middle. So what this will be, this 1 will be gone, and this will be 0. I'm sorry, this 1 will be gone and this will be 0, and this 0 will be gone and this will be 1. Alright, so okay, and then the middle is done. Middle is the increment middle, it's encountering 1. Increment middle is encountering 1. We increment middle. Okay, now middle is encountering 0, and starting would have also been incremented to here. Now this is encountering 1, this is encountering 0. When we encounter 0, what do? We swap start and middle. So let's do that, and we increment both start and middle. So when we swap start and middle, this will become 0 and this will become 1, right? And then we increment this and we increment this. Now see, the middle pointer has moved beyond the end pointer, and this is the stopping position. This is very stop. So what can we see? What is the final array? The final array is 0 0 0 0 1 1 1 1 2 2. So it has been sorted. So now we'll see the code for this algorithm. Okay, so let's try another problem. Let's take this array. Let's take the array of 2 0 2 1 1 1 0. This is the array. Okay, again the simple thing that we would be doing is that this is the start pointer, this is the middle pointer, and this is the end pointer. Okay, so we can see that middle is encountering what? Middle is encountering 2. So the first thing, so what do? We just swap this with the ending value. So this becomes 0, this becomes 2, right? And then we decrement ending by 1. Ending is pointing here. Now middle is pointing at 0. When middle points at 0, we swap middle and start, and then we move, since they are at the same position, there's nothing to swap, and then we move both of them 1 place towards the right. If we increment them 1 place. So plus 1, middle plus 1, start plus 1, right? So middle is pointing at 0, we swap, there's nothing to swap, we move both of them 1 place to the right. Middle is pointing at 2, when they point at 2, we swap middle and end. So that is this thing. This becomes 1 and this becomes 2, and we decrement ending by 1, right? Now middle is pointing at 1, we do nothing, just increment middle by 1. Middle is pointing at 1, we do nothing, increment middle by 1. Middle crosses end, the array is sorted, right? Now let us write the code for this function. The code for this function this algorithm will look something like this. We will initialize 3 pointers, that is integer start equals 0, mid equals 0, and end equals nums dot size minus 1. Right. So we have 3 cases. That is, if nums, we iterate middle, right? If num, so how long will we iterate for? We will iterate while middle is less than or equal to end, right? Because we saw middle was equal to end, and then felt like we were performing the algorithm for middle equal to end or less than end, and as soon as it crossed more than end, we stopped. So let's incorporate that condition while mid is less than is equals to end. Now while mid is less than equal to end, what will we do? We will have 3 cases, that is 0, 1 and 2. So let's have the 3 cases. If nums of mid equal to 0, we will do something. Else if nums of mid equal to 1, we will do something. And else, since we only have only one condition, we can just do away with else we'll do something. Okay, so we'll be using the inbuilt swap function. We don't have to write a swap function. That works perfectly fine over here. There's nothing, no problem with that. So when mid is equal to 0, what will we do? We will swap what will we swap? We will swap nums of middle with nums of start, and as soon as we do that, we will increment start and we'll increment mid. When it's equal to 1, we'll do nothing but increment mid, and when it's equal to 2, our else condition, will do nothing but we will swap nums of middle with nums of end, and we will do end minus 1 is incremented by 1. That's the algorithm. This should work. Let's check it out. Okay, that's the silly mistake. Let's check the entire code again. I don't think there are any more mistakes. Let's run it. All checks is passed. Let's submit it. There you go, it's working. It beats 0 ms, 100% zeros. So what's the time and space complexity for this? The time and space complexity is, see, we are sorting it in place, right? So the time complexity is nothing but big O of n, and we are not using any extra space. So the space complexity is nothing but big O of 1. We'll have constant space, right? Without taking up any space. That's it. And that's the problem. Then this is the optimal approach.